Hello my lovely students, you're welcome to a new lesson. Today, I shall be teaching you geometrical ratios. From definition, geometry is the study of the properties of shapes. Examples include the properties of lines, angles, plane shapes, and solid shapes. Also from definition, a theorem is a mathematical rule or proposition that can be proved by a method of argument or reasoning. Let's learn more about geometrical ratios. Let's learn about intercept theorems. An intercept is formed when two straight lines cut a transversal or a transverse line. An intercept is the part of the transversal which is cut off between the straight lines. We have a diagram below here to illustrate what an intercept looks like. We have two straight lines, line AB and line CD, and we have a transversal PQ cutting across the two straight lines. Now the line segment between X and Y that is cut off between the two straight lines represents the intercept. I hope this idea is clear to you. We have four intercept theorems. This includes number 1, equal intercept theorem, number 2, proportional division theorem, number 3, midpoint theorem, and number 4, angle bisector theorem. Please take note of these four intercept theorems. Let's learn more about the various intercept theorems. Theorem 1, equal intercepts theorem. If three or more parallel lines cut off equal intercepts on a transversal, then they cut off equal intercepts on any other transversal. We have a diagram below here to illustrate theorem 1, talking about the equal intercepts theorem. Here we have three parallel lines that are equally spaced and two transversals. The first transversal cuts through points A, B, and C, while the other transversal cuts through points X, Y, and Z. Here are the formulas associated with theorem 1. From the formula, if the length of AB is equal to the length from B to C, talking about equal intercepts on the first transversal, then the length from X to Y should be equal to the length from Y to Z, talking about equal intercepts also on the second transversal. I hope this idea is clear to you. Moving on, let's learn about the second intercept theorem. Theorem 2, proportional division theorem. A straight line drawn parallel to one side of a triangle divides the other two sides in the same ratio. We have two diagrams here to explain more about theorem 2. We have a triangle ABC with a line XY drawn parallel to BC in the first diagram, while the second diagram looks like the first diagram, but here we have the smaller triangle AXY flipped upwards, so that we now have an arrangement of a triangle AXY inverted upside down above another triangle ABC with the line XY parallel to BC. Let's see the formulas associated with theorem 2, talking about the proportional division theorem. From the first formula, if the line XY is parallel to line BC, then we have two formulas here. The first formula says the ratio of AX to XB is equal to the ratio of AY to YC. While the second formula here is an offshoot from the first formula, we say the ratio of the length of AX to the length of AB minus AX is equal to the ratio of AY to the length of AC minus AY. Please take note of these formulas. Looking at our second formula for the proportional division theorem, formula 2, we can see that the triangle AXY and the triangle ABC are similar triangles. Hence, the ratio of their corresponding sides are equal. So from the diagram, taking the ratio of corresponding sides, we have the ratio of AX to AB is equal to the ratio of AY to AC, which is equal to the ratio of XY to BC. We have three equations in one here. Let's see them. Here we can see that the three equations are as follows. Number 1, the ratio of AX to AB is equal to the ratio of AY to AC. Number 2, the ratio of AX to AB is equal to the ratio of XY to BC. While number 3, the ratio of AY to AC is equal to the ratio of XY to BC. Please take note of these formulas for proportional division theorem. Looking at the third intercept theorem. Theorem 3, midpoint theorem. The straight line joining the midpoints of two sides of a triangle is parallel to the third side and equal to half of it. We have a diagram below to illustrate theorem 3, talking about the midpoint theorem. Here we have a triangle ABC with the point M being the midpoint of the length of A to B, while the point N being the midpoint of the length from A to C. Using a straight line to join the midpoints from M to N, these are some formulas that we can derive from the diagram. From the diagram, if the length of AM is equal to the length from M to B, and the length of AN is equal to the length from N to C, then we have two formulas that we can derive here. From the first formula, the length of MN is parallel to the length from B to C, while from the second formula, the length from M to N is equal to half of the length from B to C. Please take note of these formulas associated with the midpoint theorem. Look at our last intercept theorem, theorem 4, angle bisector theorem. The bisector of an angle in a triangle divides the opposite side in the ratio of the sides containing the angle. We have a diagram below here to illustrate theorem 4, talking about the angle bisector theorem. Here we have a triangle ABC with the angle at A bisected by the line AM to form two equal halves, which are angles E1 and E2. Here are the formulas we can derive from theorem 4, talking about the angle bisector theorem. From the diagram, in triangle ABC, if AM bisects the angle at A and the angle E1 is equal to angle E2, then the ratio BA to AC is equal to the ratio BM to MC. Please take note of these formulas for the four intercept theorems. Moving on, let's take some examples concerning the various intercept theorems. Our first example will be testing the equal intercepts theorem. Example 1. In the diagrams below, find the lengths indicated by letters. We have four diagrams here: diagram A, diagram B, diagram C, and diagram D. In diagram A, we are looking for the length of K. In diagram B, we are looking for the length of E. In diagram C, we are looking for the length of N and P. While in diagram D, we are looking for the length of W, X, Y, and Z. From the formulas associated with the equal intercepts theorem, can you tell the lengths indicated by letters here? Let's see if you can. Looking at a solution to example 1. From the diagrams, using the equal intercepts theorem, in question A, the length of K is equal to 3.1 centimeters, talking about equal intercepts theorem. Also, in question B, the length of E is equal to 4.5 centimeters. I hope you got these answers right. Now, following this idea, looking at the diagrams in C and D, can you tell the lengths indicated by letters? Let's see if you can. In question C, the length of N is equal to 3 centimeters, while the length of P is equal to 2.5 centimeters. And lastly, in question D, the length of W is 6 centimeters, the length of X is 5 centimeters, the length of Y is 8 centimeters, and the length of Z is 8 centimeters. I hope you got all these answers correctly. Moving on, let's see our second example, which tests the proportional division theorem. Example 2. In the diagrams below, find P and U. Now, can you still remember the formulas associated with the proportional division theorem? Let's see if you can still remember. Looking at a solution for question 2a. Using the proportional division theorem and looking at same ratio internal division, we have these equal ratios. P divided by 6 centimeters should be equal to 5 centimeters divided by 4 centimeters. If you solve this equation, what would be your value for P? Let's see if you got that right. Solving this equation by making P the subject of the equation, we are going to have P is equal to 7.5 centimeters, coming from 6 centimeters times 5 centimeters divided by 4 centimeters. I hope you got that right. Now, apart from using this method to solve for P, let's see another method we can use to solve for P. Once again, to solve for P, we can use the ratio of corresponding sides being equal. That should give us the equal ratios, which are P divided by P plus 6 centimeters should be equal to 5 centimeters divided by 5 centimeters plus 4 centimeters. If you solve this equation, what would be your value for P again? Let's see if you got it right. Of course, solving again, you're going to get the same answer for P, being P is equal to 7.5 centimeters. I hope you got that again. All you have to do is to clear the fractions and make P the subject of the formula by collecting like terms. Now that we have gotten the answer to question A, talking about finding the value of P, now let's move to solving question B, talking about finding the value of U. Now looking at a diagram for question B, can you calculate for the value of U? Let's see if you can. Now looking at a solution to question 2b. Using the proportional division theorem again, let's look at the ratio of corresponding sides being equal in the diagram. We are going to have these equal ratios. U divided by 12 centimeters should be equal to 30 centimeters divided by 20 centimeters. Now if you solve this equation, what will be your value for U? Let's see if you got the correct answer. Now solving the equation by making U the subject of the equation, we're going to have 30 centimeters times 12 centimeters divided by 20 centimeters. That gives us U is equal to 18 centimeters. I hope your answer was correct. Now, apart from using the ratio of corresponding sides being equal, let's see another method we can use to find the value of U. Of course, we can use the same ratio external division to get the value of U. In doing that, we're going to have these equal ratios. U divided by U plus 12 centimeters should be equal to 30 centimeters divided by 30 centimeters plus 20 centimeters. Solving this equation by clearing fractions and collecting like terms for U, what will be your answer for U again? Let's see if you got the correct answer. Of course, solving for U again, our answer for U is 18 centimeters. Big congratulations to you if you got that right. All you have to do is to clear your fractions and collect your like terms for U as shown here. Moving on, let's see our next example for midpoint theorem. Example 3. In the diagram below, calculate the length of EC and BC. Now, using the formulas associated with the midpoint theorem, can you tell the length of EC and BC? Let's see if you can. Looking at a solution to question 3, now looking at the diagram closely, we can see that the length from A to D is equal to the length from D to B, talking about 2 centimeters. Now, using the idea from the equal intercept theorem, can you tell the length from E to C in question A? Let's see if you can. Now, the solution to question A, using the equal intercept theorem, the length from E to C is 4.5 centimeters. I hope you got that right. Now, for the solution to question B, using the midpoint theorem, can you tell the length from B to C? Let's see if you can again. Of course, using the midpoint theorem, the length from D to E should be half of the length from B to C. Solving this carefully, you will see that the length from B to C should be 2 times the length from D to E, which is 10 centimeters. That makes the length from B to C to be equal to 20 centimeters. I hope you got that right. Look at our fourth example, which tests the angle bisector theorem. Example 4. In triangle XYZ, the length from X to Y is 7 centimeters. The length from Y to Z is 5 centimeters. The length from X to Z is 10 centimeters. And the bisector of the angle Y meets XZ at P. Let's calculate Roman figure 1, the length from X to P, and Roman figure 2, the length from P to Z. The diagram for the question is shown below. Let's see the solution to example 4. Now, from the diagram, using the angle bisector theorem, we have these equal ratios. The ratio of the lengths from XY to YZ should be equal to the ratio of the lengths from XP to PZ. Substituting your values, we are going to have 7 centimeters divided by 5 centimeters should be equal to the ratio of the length from XP to PZ. We are looking for the length from X to P. But looking at the diagram closely, we can see that the length from P to Z is equal to the length from X to Z minus the length from X to P. That makes the length from P to Z to be equal to 10 centimeters minus X to P. So substituting the value 10 centimeters minus XP for PZ in our ratios, what are you going to find? Let's see if your substitution is correct. Now, substituting 10 centimeters minus XP for PZ in the ratio above, we are going to have 7 divided by 5 should be equal to XP divided by 10 minus XP. If you clear your fractions and you remove your brackets, you are going to have 70 minus 7 of XP should be equal to 5 of XP. Now, solving for XP by collecting like terms, what are you going to find as the answer for the length XP? Let's see if your answer is correct. Now, solving for XP, you are going to find XP being equal to 5.83 centimeters or 5 whole number 5 over 6 centimeters. I hope you got that right. All you have to do here is to collect your like terms for XP and finally make XP the subject of the equation. Moving on, let's see the answer to question 2. What will be the value for the length of PZ? Let's see. For the solution to question 4, Roman figure 2, the value of PZ should be 4.17 centimeters or 4 whole number 1 over 6 centimeters. I hope you got this right again. All you have to do here is to use the equation PZ is equal to XZ minus XP, which should give you 10 centimeters for XZ minus 5.83 centimeters for XP. I hope the solution to question 4 is clear to you. Moving on, let's learn about similar triangles. Similar triangles have the same shape but are of different size. Similar triangles are equiangular and have corresponding sides in the same ratio. The triangles below here, talking about triangle PQR and triangle ABC are similar triangles. Let's learn more about similar triangles. Let's see the conditions for similar triangles. We have two conditions for similar triangles. Condition number 1. Two triangles are similar if the angles of one triangle are respectively equal to the angles of the other triangle. That is, all the corresponding angles in triangle ABC and triangle PQR are equal because they are similar triangles. So what we have here is that the angle at A should be equal to the angle at P. The angle at B should be equal to the angle at Q, while the angle at C should be equal to the angle at R. Please take note of this first condition for similar triangles. Now for the second condition for similar triangles, condition 2. Two triangles are similar if their corresponding sides are in the same ratio. That is, the ratio of their corresponding sides are equal. Of course, we have seen this fact earlier under the proportional division theorem. From the diagrams, since triangle ABC is similar to triangle PQR, so the ratio of their corresponding sides are equal. That gives the ratio of AB to PQ should be equal to the ratio of BC to QR. That should be equal to the ratio of AC to PR. Once again, here we have three equations in one. The first equation being the ratio of AB to PQ is equal to the ratio of BC to QR. The second equation here is the ratio of BC to QR is equal to the ratio of AC to PR. While the third equation here is the ratio of AB to PQ is equal to the ratio of AC to PR. Please take note of these two conditions for similar triangles. Now let's see our last example for similar triangles. Example 5. Given a diagram below with QL is equal to 2 cm, LM is equal to 3 cm, and PR is equal to 4 cm. Calculate the length of QR. The diagram for the question is shown below. Let's see the solution to question 5. From the diagram, in the two triangles, looking at the diagram closely, we can see that the angle at M is equal to the angle at P, talking about 60 degrees each. Of course, the angle at Q is equal to the angle at Q in both triangles, while the angle at L is equal to the angle at R. That means triangle MQL is similar to triangle PQR. Now, knowing this fact, can you take the ratio of corresponding sides of these two similar triangles? Let's see if you can. Of course, taking the ratio of corresponding sides, we have the ratio of MQ to PQ should be equal to the ratio of QL to QR, which should be equal to the ratio of ML to PR. I hope you got these ratios correctly. Now let's go ahead to substitute the given values into our ratio of corresponding sides and solve for QR. Substituting values, we are going to have MQ divided by PQ should be equal to 2 cm divided by QR, which should be equal to 3 cm divided by 4 cm. Of these three ratios, we can see that the values of the first ratio are not given at all. That means we can't use the first ratio. We can only use the second ratio and the third ratio. Hence, the second and third ratios will give the required result. So this is what we must use to solve for QR. We must use the ratio 2 cm divided by QR is equal to 3 cm divided by 4 cm. Now solving this equation for QR, what will be your answer for the length of QR? Let's see if your answer is correct. Of course, solving for QR, we are going to make QR the subject of the equation. In doing this, QR will be equal to 2 cm times 4 cm divided by 3 cm. That gives QR is equal to 8 divided by 3 cm. Lastly, QR should be equal to 2.67 cm or 2 whole number 2 over 3 cm. I hope you got the correct answer for QR. Thank you very much for going through the lesson today. I want to advise that for you to get more information about the topic geometrical ratios, please continue to read your textbook. Don't forget to attempt your quiz and your assignment. I hope to see you again in our next class. Until then, it is goodbye for now. Thank you very much.